Hello, my name is Cormac McGarrigle and today we're going to look at the vacuum infusion process. This is a method of manufacturing composite materials. So to start out, dry materials are placed into a mould, vacuum is applied and then the resin is introduced. So we'll look at that as we start to progress through the video. The first stage as part of this process is to cut our fibre reinforcement material. In this case, we're looking at a 380 GSM, that's grams per square metre, 5 harness satin carbon fibre. These are laid up in the desired orientation. This is your preform. Again, the orientation varies depending on the desired properties and the end use of your material. We have determined for this project that we require 6 layers of the dry fabric reinforcement material. Depending on your application and your desired properties, this may vary. Following the cutting process of the preform, it is important that you clean up the debris. The next stage is preparation of our mould. Our mould will give us our final component shape. To ensure our component is not stuck in the mould following the infusion process, we need to use what's called a release agent. This prevents the component from sticking to the mould tool itself. In this case, we're going to use Miracle Gloss. We're going to use 3 coats of release agent for this project. Ensure that all areas of your infusion site are covered with release agent to prevent any issues of releasing the component. Our next stage is to lay down tacky tape. What tacky tape allows us to do is to form an airtight seal between our B face of our mould and our vacuum bag material. The next step is to apply peel ply. Peel ply is most commonly used to create a textured surface on the laminate, which is ideal for secondary laminate bonding. So as the peel ply itself is porous, this will absorb excess resin during the curing process. The next step is to cut our flow mesh or infusion mesh. So this is a polypropylene mesh which is used to assist the flow of resin into a laminate during the resin infusion process. Now we'll cut our vacuum bagging film. So vacuum bagging film is a flexible membrane which provides a gas type barrier which allows our component to be processed underneath a vacuum. You'll see the composite we are infusing today looks slightly different. This is because this composite has been through thickness reinforced by the tufting process. So that's the yellow fibre on it. That's actually Kevlar that has been put in the Z direction into the composite. We place our preform into the mould tool, followed by our peel ply or flow mesh, and then we remove this cover from our tacky tape to allow us to place our vacuum bag down. We are using these ports will allow for the vacuum to be drawn within the vacuum bag, and they'll also allow for the injection of resin into the bag system. We're going to be placing in a resin infusion spiral into our mould tool. So this plastic infusion spiral is used to distribute resin flow within the vacuum bag to try and ensure a more even distribution of resin throughout the part. The bag should now be pierced. You can see we're connecting on our tubing from our mould tool into our resin catch pot. The catch pot itself is then connected on another tube to our vacuum pump. During the infusion process, we need to achieve a vacuum pressure of approximately 1 bar. So we're going to ensure first of all that we can achieve that and that there are no leaks in our bag or in our mould. We also need to pierce the inlet port for our resin. So this is the stage where our resin is going to be injected into our component. However, we're going to clamp it to perform what's called the drop test. So the drop test is performed by pulling a full vacuum on the bag. The bag is then clamped off and the gauge is used to check is there any drop in vacuum. This would indicate a leak during the process. We're waiting 15 minutes here to ensure that there are no leaks and no change in pressure. After 15 minutes there's been no change on the gauge, so we're still holding 1 bar of vacuum. So we have no leaks at this stage, so we can continue with our infusion. Depending on your resin system, there's going to be a different ratio of resin to catalyst or resin to hardener. In this case, we are using epoxy resin, which we have mixed off camera. Our hose pipe or tubing is then placed in our newly mixed resin cup and the clamp removed to allow the vacuum to pull the resin through the dry fibre material in the form of our infusion. As the dry fibre begins to be wetted out by the resin, you can see it starts to give that black carbon colour that we're all familiar with. Once the tub of resin is nearing completion, ensure to clamp off the tubing going to it to prevent air being drawn into your part. We've mixed more resin than we require to allow for as much air to be drawn through our component as possible and pulled into the catch pot along with resin. Once the infusion is complete, clamp off both the inlet and outlet ports and you can turn off your vacuum pump. Depending on your resin system, you will have a specified cure time for this. So this component has been left overnight and we're going to debag it now. Once we remove our vacuum bag, we can start the demolding process by using a small plastic wedge. This prevents damage to our component and to our mold tool. Once the infused part has been released, you can see the peel ply and the injection and outlet ports are still attached to the component, so these need to be removed. The newly infused composite is sharp around the edges due to resin, so be sure to take care not to cut yourself at this stage. Our little injection ports, or resin infusion silicone connectors as they're also called, can be cleaned and reused again up to around 15 times. And there you have it, there is our infused carbon fibre and epoxy resin composite. Thank you for watching.